Policy-based routing has been available in older UniFi routers for a long time, but didn't exist in relatively newer routers. Finally, Ubiquiti added to the newly released network controller. Let's see how it works in this video. Policy-based routing, or PBR for short, is very simple from both configuration and concept perspective. What I'm showing you now is from a Ubiquiti's document. Even though it's for edge router, the same concept applies to the newer UniFi routers as well. Let's say you have two separate internet connections, ISP1 and ISP2. In your LAN, you configured VLAN 10 and VLAN 20. You want all the internet traffic for VLAN 10 only go from ISP1 and VLAN 20 go through ISP2. It's very straightforward, very reasonable request. I have 4 UniFi routers. This one is UniFi Dream Router, UDR. This one is the old USG Pro, UDM-Pro, and the last one is the UXG Pro. I'm showing you the exact same user interface from the 4 different routers. They are all from settings, traffic management. The only router which is showing different UI is USG Pro because the router is too old. Maybe for any new development or new features, Ubiquiti will simply skip the USG Pro because anyway, it has totally different operating system. Maybe it's too much to support new UI or new features. At least for the 3 relatively new routers, they have the exact same UI. But apparently internally, they will behave differently. For example, you may know for UDR, it only has a single one port. You have no way to connect 2 different ISPs. Apparently, even though it does have the traffic management, traffic routes feature here in the network controller, in this video, I will skip the UDR. Even though for UXG Pro, the oldest one, it doesn't have the traffic routes configuration internally from the CLI level. It has been supporting policy-based routing for a long time. So let's see how it works. When it comes to the new UDM-Pro and UXG Pro, let's examine them a little bit deeper. Let me use the UDM-Pro as an example. There are 3 sections in the traffic management. The 3rd section is for static routes. It's been there forever, so there's nothing new here, and it's not in the scope for this video. And the 1st section, which is traffic rules. This is a very interesting feature. It's kind of a combination of firewall rules, QoS, parental control, and it's a mixture of multiple different things. Ubiquiti tends to combine different network technologies into one feature in the name of being user-friendly. On one hand, yes, it might be very friendly to end users. On the other hand, it tends to lead to a situation that you have multiple technologies, but for any one of them, it's not really completely implemented. So maybe in the future, I will have a dedicated video talking about this one, but this one is not part of this video. In this video, we are going to focus on this part, which is traffic routes. Let's start the policy-based routing configuration from the USG Pro. This is the network environment I'm going to use for this video for USG Pro. For each UniFi router, I have a separate lab environment, and the UniFi router is connected to my home network. For this USG Pro, I connect the 2 WAN ports. They have different IP addresses from 2 different subnets, so that I can use these 2 WAN ports to simulate 2 separate ISP. For the LAN part, I configured 2 VLANs, VLAN 10 and VLAN 20. For each VLAN, I connect a Linux virtual machine. So the goal for this configuration is for VLAN 10, I wanted to use the first WAN part. For VLAN 20, I wanted to use the second WAN part only. In this diagram, you can see multiple subnets, but from the USG Pro, the router perspective, the subnet 2, 88, 66, they are in the WAN part, in the internet part. Subnet 1, 10, 20, they are in the LAN part. In the simulated internet part, in the WAN part, I have another Linux machine so that in the testing, I can use this client-side Linux to connect to this one, which is in the internet part, to see whether the policy works. Let's go to the system and check how it behaves before we make any changes. In the top right corner, you can see the UniFi controller for USG Pro. There are two WAN ports. They are all showing green color, and they have the 66 and 88 subnets as shown in the diagram in the left side. In the lower part of the network controller, you can see currently the load balancing setting is set as failover only, and the active one is the first WAN part. In the lower part of the screen, you can see the 3 Linux machines. Let me first check what's the IP address for the WAN machine. The subnet is 2 as shown in the diagram. Now let's see from the VLAN 10 machine how the routing works. Let me run traceroute. I will use the IP address for the Linux WAN machine. It first reach out to the 10.1 gateway for the UniFi router, and then route to my pfSense router, which is 66.1. Then it reach this Linux machine. So the traffic comes from VLAN 10 and go to this LAN part and go to this WAN part, reach pfSense, and then go to this Linux WAN machine. Everything makes sense. It's using the 66 IP address, which is the WAN part. And in the VLAN 20 part, let me do the same thing. Exact same result. But what if I change the load balancing to distributed? Let me keep the default 50-50 balanced, apply changes, and I will run the same traceroute command in the 2 Linux clients. Let's see what will happen. First, run the same command in VLAN 10. It's using the 66 IP address, which is the first WAN part. And for the VLAN 20, it's using 88, which is the second WAN part. It makes sense. It's 50-50, right? Let me change it back to failover only. Now we are ready to configure the policy-based routing, and then let's see how the routing works after the change. Ubiquiti has an online document for policy-based routing, even though it was intended for edge router, because USG Pro use the same operating system as edge router. The CLI works in the same way, so you can use the same approach to configure PBR in USG Pro as well. Later we will move on to UXG Pro, which is using totally different operating system, so the configuration works in different way. Let me SSH into the USG Pro. Go to configuration mode. The way policy-based routing works in USG Pro is it needs to first match IP addresses using firewall rules, and then forward the traffic using dedicated routing tables, which means in our configurations, we need to do two things. We need to add the two different routing tables for the two different routes, and then we need to create corresponding firewall rules. First, add a route to table 10. You can give the table number whatever you want. The all0 IP address means this route is the default route. I'm going to use the 66.1, which is the first ISP. Okay, successful. Run similar command, but this time 88, another ISP, and this time let me use table 20. Done. Next, we need to create the firewall policy, which is the modify firewall policy to match the VLAN IP addresses. Just give the rule a number and a description. Then we will say, okay, match IP address like this, which is the range for VLAN 10. Okay, I missed a rule number 10. Let me add it. Right, okay, done. We already created the rule, and now let's use it on the routing table we just created, which is the routing table 10. Okay. Yep, so we are done with the first one part. Then let's move on to the second one part using similar command. Rule number 20 with the VLAN 20 as description. Then for this 20 rule, let's match the source IP address 20 subnet. Then let's use it on the routing table 20. Okay. Next, we need to apply the just created firewall policies in the inbound direction on the two VLAN interfaces. Remember, we have two VLAN created on the same physical LAN part. So the way to run the command is like this. What we are saying is I will apply the firewall policy in the inbound direction, and which is the modified PBR policy we just created, and then on this physical Ethernet part on this virtual interface 10, which is our VLAN 10 interface. So I won't show you the details how you can get the physical part and the VIF number. You can simply check the system configuration to find it out. Let me correct the typo. Okay, done. Similarly for VLAN 20, right? Okay, done. In the end, let me commit changes and then save. So we are done with the CLI configurations. Let's test it. We are back to the screen layout for testing. I already typed the same traceroute command in the two Linux virtual machines, and let me run them. Let's check the result. From VLAN 10, it's using 66. From VLAN 20, 88. That's exactly what we expect. Currently, it's failover only load balancing. It works already. So let's see, without changing the policy-based routing in backend, let's simply switch it to distributed. Let's test it again to see whether the policy still works in the same way. Okay, for VLAN 10, it's using 66. For VLAN 20, it's using 88. So it doesn't matter what's the load balancing you change to, policy-based routing always works. This is the simple demo for USG Pro. You can check the Ubiquiti document for more details. Now let's move on to the newer UniFi router operating system. UDM-Pro and UXG Pro work in the same way when it comes to policy-based routing or traffic management. So in this video, I'm only going to use UXG Pro to showcase how it works. So in this diagram, you can see it's almost the same if you compare with the USG version. So we have the same subnets, the same two Linux client-side machines and one Linux one-side machines, and we want to achieve the same goal. For VLAN 10, we only want to route through one VLAN 20, WAN 2 part. Let's go to the system. The same screen layout as previously. First, SSH into UXG Pro. Okay, we are in. So the difference between UDM-Pro or UXG Pro with the earlier USG Pro is they use different operating systems. So the newer UniFi routers using the new Linux-based operating system, and the old CLIs won't work, and many functionalities are implemented using the standard Linux network features. Because we are talking about UXG Pro, as you can see in the diagram, it has 4 ports, 2 WAN ports, 2 LAN parts. We need to figure out which part is for WAN, which part is for WAN 2. Of course, you can go to the network controller to find it out, but we can also do it in the command line. Let me run standard IP command. I want to show all the links in the end of the long list. Even though we only have 4 physical parts, here you can already see 16 interfaces. Pay attention to the S3 ones, because just by the naming convention, you can already tell. So for example, this one, it means it's the VLAN 10 based on the physical S3 part. Let's check the original routing table before we enable the policy-based routing. As you can see in the diagram, we have two WAN ports. The first one has 66 subnet, the second one 88 subnet. And for LAN, we have the default 1 subnet and then 2 VLANs. Let me run the command IP route in SSH. Very simple initial routing table. The first one is for the LAN gateway, the second and the third one for the two VLANs, the fourth one and the last one, they are for the two WAN ports. Pretty straightforward. If I run another command, IP rule, this will be a little bit complicated. We won't have time to cover everything. For the 88 subnet, it's using this table, 66 using another table. We can run the command IP route show table, let's say 201, to see the details for the 201 routing table. Very simple. For 66 subnet, it's using the S2 port. As you can see in the diagram, we have 4 ports, 0, 1, 2, 3. So S2 is the first WAN port. For first WAN port, we have the 66 subnet. I want to show you the output for the 3 commands just to understand before we change anything how the routing works. Let's validate that currently, no matter from which VLAN, the internet traffic is always routed through the first WAN port. In the VLAN 10 Linux machine, let me run traceroute against the Linux WAN machine's IP address through the 66, which is the first WAN port. Okay, as expected. Move on to VLAN 20. The same result. Why? As you can see now, we have two WAN ports. They are both showing green color, but because we are testing the UXG Pro, unfortunately, it doesn't support the load balancing yet. It only supports failover. That's why you can see for the first WAN port is active, the second WAN port is backup. By default, if we don't change anything, the internet, the WAN traffic will only go through the first WAN port. Now let's enable the policy-based routing. Let me go to traffic management, create traffic route. For category, I want to say internet. For source, VLAN 10. As we mentioned in the diagram, for VLAN 10, we want to use the first WAN port. Let me select the 1 as the interface. That's it. Add route. Similarly, create another route for the VLAN 20. Internet. VLAN 20. Interface. Second WAN port. Add route. Okay, so we are done in the network controller already. Let's double check in the internet section. As you can see, nothing's changed here. They are both showing green and only the first WAN port is active. The second one is backup. Then let's go to the SSH to see what's the routing settings. Run the IP route command first. Nothing's changed because we don't have any new interfaces, but let's check the IP route command. As you can see, these two lines are new. There are some special thing here. It's called FW mark. We will talk about this later. Let's check the lookup table. 202, 201, which existed before we enable policy-based routing, but let's check what's inside the table. Show the table 201. The same information for 66 subnet through first WAN port. And let's check another table, 202. Nothing special. So for 88 through S0, the second WAN port. These two lookup tables, they are not special. They don't lead to the effect of policy-based routing. We need to check this part. To explain what FW mark is, we need to talk about two Linux commands. First one is iptables. The second one is ipset. Let me rearrange the windows so that we can better explain them. On the screen, I only show you 3 windows. The wide one is for the SSH. attach, I move the other Linux virtual machine to this part. The reason I need to show you the Linux virtual machine is to show you the menu for the two Linux commands. Let's talk about iptables. Iptables is a standard Linux command. It's available in the operating system for the UniFi router. Normally, if you want to check how it works, you run the man commands, right? But I believe because Ubiquiti wants to save some disk space, it doesn't include the menus for the standard commands. It doesn't matter. We can use whatever Linux virtual machine to check it. For example, I want to use this VLAN 10 Linux virtual machine just to check the menu page for iptables. It's a very complicated command. We won't explain all the details. The command I want to run here in the SSH is like this. iptables n means I want to display the address using the numeric one. For example, 0.0.0, which means anywhere, right? So I want to see the numeric format. And then capital letter L means list. I want to display the table, and the table name is mango. Let's see what's the mango. In the menu page for iptables, we can find the specification for mango. T means I want to show the packet matching table, and the table name is mango. It explains what's mango. This is used for specialized packet alteration. It has some built-in chains, for example, pre-routing. Basically, before the system even routes the packet, it will mark it. It will change something. That's what we want to see. So let me run the command in the SSH session. There are a lot of information, but let's focus on the very last part. Chain Ubiquiti OS pre-routing PBR. So PBR is policy-based routing, right? As you can see, it will mark the packet from anywhere to anywhere as long as it match this. This is called match set. We will talk about the match set later. See this part? It will mark the packet using this special mark. This is what we see in the IP rule section. If you forget it already, let me run the IP rule command again. See here, FW mark, this special mark, and the other line, this special mark. We need to understand what are the match sets here. It seems it means some special IP address range, but let's make sure that's the case. Now we need to talk about another Linux command, ipset. In another Linux machine, let me run the man page for ipset. We won't talk about the details. Basically, using this command, we can understand what are the match sets mentioned here, right? Let me run a command to display this match set. Copy the name, ipset list. Then I want to display the details for this set. Let me paste. Okay. It's just explain you what's this match set. It simply include these two. It's a grouping thing. It include other two sets. And to understand furtherly, let's see what's inside this set. Let me copy it, run the similar command, ipset list. With this, just copy it set name. Okay, so this is a very straightforward set. It simply means in this IP address range. What's this IP address range? It's for our VLAN 10. Clear the screen and run the IP rule command again. This line is for the VLAN 10. This line means, okay, as long as your packet has this mark, it will use this table. Let's display this table again. Show table 201. It's a very simple rule. So basically, the internet traffic will go through this part, which is our first one part. This is the gateway, right? As long as your IP address is from VLAN 10, it will route through this one part. This is exactly what we set in the network controller, right? Let me show you the rule we just created in network controller. Let me go to the first one. So what we say here is if it's VLAN 10, we use the first one part. This exactly translates to this line I just highlighted. So basically internally there's nothing special. Ubiquiti simply use the IP table, ipset to implement this so-called traffic route. Let me restore the original screen layout. Let's test whether our policy-based routing works or not. Now in the VLAN 10 Linux machine, let me run the same traceroute command. No surprise, it's using the 66. Let's check VLAN 20. This is the difference. Now it's using 88. That's exactly what we want. Okay, so far you already see, based on our testing, policy-based routing works, right? I should have ended this video here, but there's still one more thing I want to show you. Remember, this UniFi router is UXG Pro. Currently, it doesn't support weighted load balancing yet. It only supports failover. The further testing I want to do is I want to disable one of the WAN ports without changing the existing policy-based routing. Let me see whether I can still access internet from both of my VLANs without changing any settings. Let me go to the UXG Pro, go to settings. Currently we have two active ports, right? Let me disable the second one part. Go to ports, configure interfaces. For the 1, 2, let me say disable. Apply changes. See here now, we only have the first one part available. The second one is already disabled. Now let's go to the traffic management. The two traffic routes, they are still here. But let's see for the two VLANs whether the routing still work the same way or it's already changed automatically. Let me try VLAN 10 first. Okay, it's through 66 as expected. Try VLAN 20. Okay, see, it's automatically adjusted. So even though I initially say, okay, for VLAN 20, I want to use the second one part, but because I disabled the second one part to simulate a internet ISP failure without any manual configuration change, the system automatically switch to the active one part. To furtherly understand how the system magically make it happen, let's check the IP rule setting in SSH again. Okay, let me clear screen, run the IP rule command. It only has one single rule. The second one, for the second one part, that rule just simply disappeared. Show the IP tables for the table mango. Change the typo here. Let's check the very last part. It only has one mark defined. Let's check what's this mark. Let's say ipset list. Similarly, it included the two members. Let me copy the first member. Then run the ipset command again. There's no change at all. It still only match the VLAN 10. Then let's go back to the IP rule to understand how VLAN 20 works. If it's VLAN 10, it will use this rule to look up using the table 201, right? But for VLAN 20, of course, it doesn't match this rule. So it will continue. It will use this rule. And because the same table 201 will be used, if you forget it already, let me show you the table content for 201 one more time. Okay, it's using the 66, right? The first one part. So which means the VLAN 20 will use the first one part. That's how the system automatically make it happen when we disable the second one part. Okay. I hope after this a little bit detailed explanation, you understand how the policy-based routing works in the new UniFi routers. Okay, thanks for watching.